We want to work on the theorem on parallelogram. Theorem on parallelogram. Theorem on parallelogram. Theorem on parallelogram. Theorem 1. Theorem 1. The opposite sides of parallelogram are equal. 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 So, we want to prove. We want to prove. They said the opposite sides of parallelogram are equal. We have A, B, C, D. So we want to prove. The first thing you do is you draw a parallel line. You draw a what? A parallel line. When you draw a parallel line, you draw a parallel line. You draw a parallel line. So when you draw a parallel line, you divide it into two. When you divide it into two, then we'll now start this proving. Now this means, this sign means these two sides are equal. This is equal to this side. This side is equal to this side. This sign means equal. This sign means equal. This sign means equal. Whenever you see any sign like this, it's telling us that these two sides, this side is equal to this side. It means the length here is equal to the length here. The length here is equal to the length here. That's what it means. These two also means equal. It means these two are equal. The length here is equal to the length here. The length here is equal to the length here. That's what it means. This sign, whenever you see this sign, it means equality. It means this line here is equal to the line here. The line here is equal to the line here. So that is what it means. So we want to prove. I've said earlier, AD will be equal to BC. There is no reason. Once you see this sign, the sign means they are equal. This sign, AB, is equal to DC. Two of them, they are both what? They are both equal. That's what it means. Now, if AD equals to BC and AB equals to DC, what's the next thing to do? The next thing to do is that, what's the next thing to do? Very simple. The next thing to do is you start with it. You start proving, because we want to prove how opposite sides are equal. How this is equal to this and this is equal to this. So how do we prove? We prove by alternate angle. Now, I told us earlier that this side is equal to this side. We call it alternate angle. So if I want to draw an alternate angle, this is an alternate angle. This line here goes this way. So this sign and this sign, if you look at it the way it is, this is A, B, C, D. A, B, C, D. So what does that mean? It means the angle that you have here is equal to the angle here. That's the implication. If this side is theta, let's assume this side is theta, this side automatically becomes what? Theta. If this side is theta, this side is automatically what? Theta. If this side is theta, this side becomes what? Theta. I've said earlier, this is what we call what? This is what we call alternate angle. So if you want to tell us that this side is equal to this side, or you decide to make this E, this side automatically become what? E. Reason, E equals to E. This side becomes E too. What's the reason? It means this line here, AB, is equal to what? Is equal to DC. What's the reason? We have alternate angle. Alternate what? Alternate angle. That is alternate angle. That is what? Alternate angle. Now the same thing, if you go this way, this form, we can decide to go, it depends on the side you are looking at. We'll look at this side first. This side first. I use E. E is equals to E. That means AB equals to DC. That is alternate angle. So E equals to E, that is equals to AB, which is equals to DC. We call it alternate angle. That's alternate angle. Now the same thing, we can decide that we want to go this way. This one depends on which form in which you are looking at it. Depends on which form. Remember that I've said, I've proved this using what? Alternate angle. That this line here is equal to this line. Now you want to prove this line, this particular line, that this line is equal to what? To this line. We want to prove that one. That's the next thing to prove. That this line is equal to this line. So looking at this line here, we want to see how it's equal to what? To this line. That's the next thing to prove. That's what? The next thing to do what? To prove. So you can prove it in another form. Another form of proving it. Although you can prove it in forms of sum of triangle too. Sum of triangle. For this one, I'll prove it in terms of alternate angle. Let's prove it in form of sum of triangle. So looking at this now, this side, we have A or B, C, B, A, C is equals to theta. BAC is equals to theta. BAC is equals to theta. Now, if BAC is equals to theta, which is still the same thing as 180 sum of a triangle. Sum of a what? Sum of a triangle. It's still sum of a triangle. So ABC is still equals to sum of a triangle. You can prove it that way. Or you can write BAC equals to theta. Then DAC is also what? 180. Mommy, ẹ wò mí ìfẹ́ kẹ́ máa ṣépè ní ibi kámẹ́rà mi, ó máa yọ jáde.